today we're going to start our transformations real quick unit. So a transformation is just some kind of action that moves a figure in some way. So I have all of these written down. I'm just going to go through them real quick. If you want to pause this at any time to write anything down, you're welcome to. So I just have some different little puzzle pieces to illustrate this. This is like the back side of a puzzle piece, like the cardboard. This is a piece that's been flipped over, and so the figure, if it flips, that's called a reflection. These are the same two pieces, just one of them is moved over slightly, or a slide. That's called a translation, when you just kind of shift a figure in a certain way. And then here, these are the same two pieces. This piece is turned a completely different direction, and a turn is called a rotation. And then I'm just going to give you a couple definitions down here underneath. So what we call the pre-image is the original piece, or the original figure. So here is just a little example as a diagram. So I have a triangle, JKQ, that is the pre-image. The image, in this case, this is a reflection. I'll kind of draw the reflection line in here just a little bit so you can see it. This one's being flipped over, and what we do is the image is what happens after you do the transformation. So the image is going to have primes in it. So this is K, this is K prime, this is J, this is J prime. It almost looks like a little exponent of a 1 is what it looks like, but it's called a prime. So it's just a reflection over this line here for this little example. So this just says triangle JKO is going to be transformed into J prime, K prime, O prime. JKQ maps onto that. Okay, so your pre-image, that's your original. Your image, it's like what we have here after you have performed whatever the transformation is. And just a word to know, an isometry, which is what we're going to be dealing with today, it just means the pre-image and the image are exactly the same as each other in terms of congruence. The sides are the same length, the angles are the same measure. So if your original shape and your new shape are exactly congruent to each other, then that's going to be what we call an isometry. So the first transformation we're going to talk about here today is a reflection. And you guys can read through this. It's an isometry, so both the original and the pre-image and the image are going to be congruent. And it has opposite orientations. We're going to have things go in a different order. Reflective image mirrors and appears backwards. So this is just kind of a little explanation that's pulled out of a textbook. A line of reflection. Here's just a point and it's reflected. Here's another point A and it's reflected. If it's on the reflection line, it is possible for the pre-image and the image to be the same if it's on the reflection line. If it's not, it's a perpendicular segment that reflects it at exactly the same distance over that reflection line. And then here's just a little example, and you guys can see how the letters go in a different order. They're congruent. You have BUG for bug, that's your pre-image, your image, B prime, U prime, G prime, and you can see this goes BUG if I'm going around this way, and then here it goes backwards, BGU if I'm looking at it the other direction. It's oriented opposite. So what we're going to talk about here, I've got some figures drawn in the coordinate plane, just how do we reflect them. Okay, here's all you have to do, and I just want to show you, sometimes these might be labeled in a different way, but we're going to take this triangle and reflect it over the x-axis. You might see how to write this. You might see a capital R for reflection, and then you might see x-axis. That's another way to indicate that you're supposed to reflect over the x-axis. So just a little different notation there that you might see. So here's my x-axis. I'm just going to kind of highlight that. That's my reflection line. And literally, I just count. So B is one spot away. So over the x-axis, B prime would be right here. A is 1, 2, 3, 4 spots away, so just go 1, 2, 3, 4 spots away. Here's A prime. C is 3 spots away from the x-axis, so C prime right here. Play connect the dots. and there's my reflection. This one's a little weird. It's that same triangle, but we're going to go over the y-axis. And just remember another notation, you might see a capital R and then it'll say y-axis. That's another indication you want to reflect. So here we just go over the y-axis. 3 spots away, so 3 spots away. This will be A prime. C is 2 spots away, so 2 spots away along the same line. That'd be C prime. And then B is on the reflection line, so B prime. So, oops, I didn't do a really good job drawing that. These two have an overlap when you're drawing that properly. Sorry, I drew that A prime a little bit weird. But that's okay. They can touch each other. They don't have to be completely separate like they were here. You're just reflecting the points in the way it says. And then I have one more down here. This is another triangle. Now this says draw the reflection over x equals 2. So I just want to remind you, vertexal and horizontal. So x equals 2 is going to be this vertical line. I call it vertexal because all the x coordinates are 2 there. And then again, remember, you might see like r and then x equals 2. That's just saying reflect over that line. So again, I'm just going to kind of count. So I is 1 spot away. Here's I prime. G is on the reflection line, so G prime will be also. And then H, 3 spots away, so 1, 2, 3. Here's H prime, and then just go ahead and connect the dots there. Whoops, that doesn't look really good. But there's your reflection over x equals 2. And here I just have a couple examples that ask you to reflect over a line, but they don't appear in the coordinate plane. So for anything like this, just do your best to sketch. But I'm literally just going to flip this. This is kind of a diamond shape to the best of my ability over that line, trying to do it about the same distance. I probably made a little bit too much of a gap. Now the white triangle would be first, and then the black triangle is going to be on the outside, so this part should be shaded in on my attempt to reflect that, but that's all you're doing. Here I'm going to try to reflect the smiley face. This is going to be a little bit trickier. So here's the smile going this way, so on the reflection would go upside down. I'm going to try to put the eyes kind of here, and not the best rendition, but you're just trying to sketch when you do this. Draw the reflection line. Try your best to just kind of sketch in. If I were to fold the paper in half on this line, the pre-image and the image would line up. So something like that there. Something like that there. If we folded the paper in half on that line, the two triangles would match up. That's what you're looking for a reflection line. And then real quick, we're also going to talk about translations today. So translation is a slide. Okay, so you're basically taking a point. Here I've got V and A, and we're just sliding it. It's still going to have a prime, so the pre-image is your starting point, your image is your second. Wherever you end up, that's going to have a little prime on it. So, forgive me, the little triangle symbols didn't print out here on my paper very well. So this is triangle AMY, so what we're doing is translating 5, 1. Okay, there's several ways this can appear. You see a T, and you might just see a little vector. It'll say 5, -1. What this means is you're going to go right 5 and down 1. So the first number is just like your x coordinate, the second is like your y coordinate, so that you're going to take the point, you go 5 to the right, down 1. Now another way this can appear, sometimes what they'll do is they'll write the same thing. So x, meaning the x coordinate, if it's +5, you would go 5 to the right, and then y -1 since we're going down. So that's another way that that can be given to you in terms of notation. Usually if you see this format where it just gives you the vector, you'll see like an x, y after that to let you know this is the x, this is the y. But these are just two different ways to write a translation. But a translation is literally just going to take the pre-image and shift it maybe left or right and then up or down. Okay, so just here, just a little example. So this could appear here 3, -6. This could also appear, that first number is going to go with the x, so it'd be x plus 3, y minus 6. So describe this in words, this is going to go right 3 and down 6. And then make a vector for the translation. So if I'm going left 8, that would be -8, and up 9, that would be +9. So the vector, you could write it several different ways. Little notation, this is telling you the xy, or translation, this would be x minus 8 comma y plus 9 in the vector, and that's just telling you what direction you're going to point the image. Okay, so here's all you have to do in the coordinate plane. I went ahead and graphed these. So this says we're going to take each point under the translation. So again, you might see this like x plus 4, y minus 2. You might see it like this, 4 comma -2. What it just means is we're going to, every single point, take 4 to the right and down 2. So here's B. We're going to go 1, 2, 3, 4, down 2, 1, 2. Here's B prime. Here's D. Over 4, 1, 2, 3, 4, down 2. Here's D prime. C over 4, 1, 2, 3, 4. Oh, oops, not there, sorry. And then down 2. Sorry about that. This is the C prime here. And then A over 4, 1, 2, 3, 4, and then down 2. This is A prime. And I'll go ahead and pretend I didn't put that extra little dot there. And then your pre-image is what I've got in pencil, and your image is what I've got in my green pen after I've slid that. And lastly, I've got some translations in the coordinate plane here, and this says describe it from the graph. So what you're looking for, your pre-image just has the plain letters, so like Q, R, S, P. What am I doing to Q to move over here to Q prime? So I'm just going to count. So I'm going 1, 2, 3, 4. So I'm going left 4, so I'm going to make that a -4, and then I'm going up 1. So the vector, to describe that, can do this several ways. Like I said, I'm translating 4 to the left, up 1, or you can write it, this would be x minus 4, y plus 1. It's what am I doing to the x coordinate, what am I doing to the y coordinate. This example, here's your pre-image ABC, A prime, B prime, C prime. And so what am I doing? And you can pick any point. They should be the same because these are isometries here. So let me just pick B. What am I doing to B to get over to B prime? So I'm going 1, 2, 3, 4, 5, 6, and then down 1. So I went 6 to the right, down 1. So there'd be my vector. So 6 comma -1. Or I'm adding 6 to the x coordinate, and I'm subtracting 1 from the y coordinate.